Hello, this will be our second lesson of the school year. This will be lesson 1.1b, and we will be talking about opposites today. So let's get started. Let me share my screen with you and present. Okay, like I said, today we're going to be talking about identifying integer opposites. So if you don't know what an integer opposite is, by the end of the lesson, you will. So the standard is I can find the opposite of an integer. We'll be working from the same standard as the last lesson, NS5. And remember, at any time during this lesson, this video, you can pause it, take notes on things you want to remember. You're welcome to do that. You're also welcome to watch the video again. And when you get those questions periodically throughout the video, feel free to rewatch the video and try again. So you are definitely welcome to do that and encouraged to do that. So our standard is understand that positive and negative numbers are used together to describe quantities having opposite directions or values. We are focusing on the opposite directions and values today. We are going to use positive and negative numbers to represent quantities in real world contexts and explain the meaning of zero in each situation. We've already talked about a little bit about real world quantities and integers, and we talked about sea level, and we talked about elevation, we talked about temperature. We're seeing that integers can be used in real world situations. And we also have started to talk about zero. We'll be doing that a little bit more today. So let's get going. Let's start with a little bit of review, and I'm going to minimize myself so you can see the screen. I'll come back on in a little while. Okay, the number line. Let's review the number line. There's our number line at the bottom. And remember that the positive numbers, the positive integers go to the right, and the negative integers go to the left of zero. And we know that zero is neutral. It is neither positive nor negative. Negative integers are less than zero. The numbers get smaller the farther from zero you get. And positive integers are greater than zero. The numbers get bigger the farther from zero you get. And zero, again, I said, is neither positive nor negative. Something to keep in mind is as you go to the right, the numbers get bigger and bigger and bigger and bigger and bigger. As you go to the left, in this direction, the numbers get smaller and smaller and smaller and smaller and smaller. That's another way of looking at this, so keep that in mind, especially in our next lesson that we will be doing after this one. Okay, a little more review. What is an integer? Oh, do you remember? Did you say a positive or negative whole number? Remember, whole numbers are numbers that are counting numbers. 1, 2, 3, 4, 5, etc., or -1, -2, -3, -4, -5, etc. They are not the in-between numbers. So integers are not the numbers in between. So 1/2, 3/4, 1.25, 60.3784, none of those in between numbers are integers. They're only the whole numbers. So there's an example, 3.5 is not an integer. That should be review for you. A little more review. Number lines, we said, can be vertical. We did that on our last lesson. Here's a vertical number line. Positive numbers go up. Negative numbers go down. Just turning the number line on its side. So which is a greater integer, positive 7 or positive 300? What do you think would be a greater integer? Which number is bigger? So they're both positive, so we're going to go farther from zero. That's going to be the bigger number. So that one should be easy. 300 is bigger than 7. I would rather have $300 than $7. So I think that 300 is way bigger. What about when you get to negative integers? Then it gets a little bit trickier. Which is a greater integer? Negative 7 or negative 300? Which one is a greater integer? This case, we're talking negative numbers. So we want the number that's closest to 0. That's the bigger number. So did you say negative 7? Negative 7 is much closer to 0 than, we'll put negative 7 about right here, than negative 300, which is way, way, way down here. So far down, I can't even show it on the screen, right? So negative 7 is the bigger number. That should be reviewed for you. What about sea level? We talked about that yesterday. Sea level is 0, right? And then elevations that go up above sea level get higher, right? Like the mountains. If you get way, way up above sea level, you're in the mountains. If you go way below sea level, you're like the scuba diver, you're under the sea. So let's take a look. A diver is 15 feet below sea level. What number represents the elevation of the diver? He's 15 feet below sea level. What number? Did you say negative 15? Awesome, then you are doing an awesome job. Which integer is closest to sea level? Here are your choices. Which integer is closest to sea level? Doesn't matter if it's above 0 or below 0. Above sea level or below sea level. It just has to be closest to 0, okay? So let's get rid of the negative 7 and the positive 7. They're farther away, aren't they? Negative 7 is over here somewhere. Positive 7 is over here somewhere. And then we got negative 1 to choose from and positive 2. Which one are we going to get rid of? Exactly. Positive 2 is not as close to 0 as negative 1, right? This positive 2 is going to be somewhere like this. Negative 1 is really, really close to 0. It's only 1 unit away from 0. So negative 1 is the answer. Which two integers are the same distance from sea level? Here are your choices. Negative 5, positive 6, negative 12, positive 5. Which ones are the same distance from sea level? Just maybe on opposite sides, right? Well, we can get rid of 6 and negative 12. So negative 5 and positive 5 are just on opposite sides. So we have positive 5 over here and negative 5 here. They're both 5 units from 0. One is above 0, one is below 0. Which integer has the least elevation? Here are your choices. Least elevation. That means which one is lowest under the ground? Which one is farthest away from 0 going in the downward direction? Let's get rid of negative 1. That's pretty close to 0, isn't it? Let's get rid of negative 19 and negative 4. So negative 21 is the farthest below 0. Negative 21 is down here. Negative 21. Okay, good job. Let's continue. Okay, you get a turn to review a little bit, so I'll see you back after you answer a couple of questions. Okay, how did you do? Hopefully well. I'm sure you did awesome. This is a great group of 6th graders. Okay, we're going to talk a little bit about opposites. Opposites are just two sides of the same coin, so to speak. Let's take a look. Two numbers are opposite if on a number line they are the same distance from 0, but on different sides. We'll look at something here. Different sides of 0. So two numbers are opposites if on a number line they are the same distance from 0, but on different sides of 0. So let's do an example. Which number is the same distance from 5 on the number line? Let's put 5 there. There it is. Now we want to go on the opposite side of 0. Which number is 5 units from 0 going the left direction? Did you say negative 5? Great job, because we can see we count from 0. We've got 1 unit, 2 units, 3 units, 4 units, 5 units. 5 units from 0 this way. And if I go the other direction, 1, 2, 3, 4, 5, I have 5 units from the other direction left. So 5 and negative 5 are opposites. They are the same distance from 0 on opposite sides. Let's try another one. Opposites. Which number is the same distance from negative 7 on the number line, only on the opposite side? Well, we'll plot negative 7. There it is. Which number is 7 units from 0 on the other side? On the right side. Did you say 7? Then you are correct. So negative 7 and 7 are opposites. They are the same distance from 0, but on opposite sides. Here's another one. Which number is the opposite of negative 10? Let's plot negative 10. There it is. Which number is 10 units from 0 on the opposite side of 0? Did you say positive 10? Awesome. Negative 10 and 10 are opposites. They are the same distance from 0 on opposite sides. More about opposites. What is the opposite of 0? Think about that one for a second. What is the opposite of 0? Remember the definition. Opposites are the same distance from 0 on either side of 0, but 0 is right in the middle. Well, there's 0 from the left, and there's 0 from the right. 0 is its own opposite. So you could say the opposite of 0 is 0. 0 is the same distance from itself, just like you're the same distance from yourself. 0 is the same distance from itself. It's its own opposite. Okay, let's take a look at something else. We're going to graph some opposites. Graph 3 on the number line and then graph its opposite. Okay, let's graph 3. There it is. What's the opposite of 3? Did you say negative 3? Awesome. Now we're going to graph negative 3. There we are. 3 and negative 3 are opposites. They are the same distance from 0 on opposite sides. Graph the opposite of negative 1. Okay, this is a little bit trickier. We are graphing the opposite of negative 1. So we're going to have to work backwards. So first we're going to work with the negative 1. We'll draw a little line here. And then we're going to work backwards to the opposite of negative 1. And then we're going to work backwards to the opposite of the opposite that we found. So what do I mean by that? Well, let's graph negative 1. There we are graphing negative 1. Now we have to graph its opposite right here. Graph the opposite. So let's do that. The opposite of negative 1 is positive 1. So we're graphing the opposite. Now we have to graph the opposite of positive 1. What's the opposite of positive 1? Exactly. We're back to negative 1 again. So when you see the question, graph the opposite of a number, it turns into the number itself. So graphing the opposite of negative 1 becomes negative 1 again. So here's your rule. The opposite of any number is the original number itself. So if I was to graph the opposite of negative 8, I would end back up on negative 8. If I was to graph the opposite of positive 7, I would end back up on 7. Now it's your turn to give this a try. I'll see you back in a minute. Okay, how'd you do on those? A little bit trickier, right? Now let's talk about some higher order thinking. What is the opposite of the integer 3 units to the left of -7? Again, this is one of these problems we need to work backwards on. So we need to work with the -7 and graph that. And then we have to go 3 units to the left of -7. And then we have to graph the opposite of where we land. So for example, we're going to start on -7. There it is, graphing that. And now we have to go 3 units to the left of -7. So how would I go 3 units left? Well, I have to count them, don't I? 1, 2, 3 units left. Where did I land? Right, I landed on -10, right? Okay, let's clear that. And I think I have that automatically doing that for us. 3 units, we land on -10. Circle my -10 again. And now we have to graph the opposite of the -10. So what's the opposite of -10? +10. Okay, so give those type of problems a try. Let's just try one more. What is the opposite? Let me just type one in here. Get a little bigger. What is the opposite of the integer 2 units to the right of 5? What is the opposite of the integer 2 units to the right of 5? Well, work backwards. First, we're going to graph our 5. So we're going to graph 5 right here. Make it a little bigger than the other circles so you can see what's going on. So what is the opposite of the integer 2 units to the right of 5? So now we put the 5 there. Now we gotta work backwards and go 2 units to the right of 5. So 1 unit, 2 units. Now we're on 7 and we have to now graph the opposite of 7. What's the opposite of 7? Right back here at -7. Okay, so that's just another example for you. Okay, let's move on a little. Okay, here's a word problem for us. Real world context, like our standard says. 3 contestants are competing on a trivia game show. The table shows their scores before the final question. So we have 3, my little box here. We have 3 contestants. We have Timothy, we have Shauna, and we have Kaylin. Timothy has a score of -25 currently. Shauna has a score of 18, and Kaylin has a score of -14. Let's answer some questions about the table. First question on the bottom of your screen there. How many points must Shauna earn for her score to be the opposite of Timothy's score before the final question? How many points must Shauna earn for her score to be the opposite of Timothy's score? Well, let's go up and think about what's the opposite of Timothy's score. What's the opposite of -25? Right, +25. So how many points does Shauna have to earn to get up to a +25? How would you figure that out? Well, you could count on your fingers. You're at 18. You can count up 19, 20, 21, 22, 23, 24, 25. Or you could subtract 25 minus 18, right? 25 minus 18. How do I subtract? If you remember from last year, I can't take 8 from 5 because it's bigger than 5. So I'm going to borrow from the 2. Make the 2 a 1. I'm going to make the 5 into 15. So 15 minus 8 is going to give me 7. So how many points must Shauna earn for her score to be the opposite of Timothy's score? 7. She must earn 7 points. There's your 7 points. Okay, next question. Which person's score is closest to 0? Got to visualize our number line here, and you got to think, It doesn't matter if the score is below 0 or above 0, to the left or to the right of 0. It just matters how close it is to 0. Which number is closest to 0? Did you say, Kaylin? Negative 14 is closest to 0? Exactly. It's 14 units from 0 on the left side. Shauna's is 18 units from 0 on the right side, and Timothy is 25 units from 0 on the left side. Last question. Who do you think is winning the game before the final question? Who's winning the game right now? Who's got the biggest score? Who's got the highest score? Did you say Shauna? Shauna's got 18, right? She's the highest score, right? There we go. Okay, now it's going to be, oh, we'll try one more here. Find the distance between 6 and its opposite on a number line. So let's plot 6. What's the opposite of 6? Right, negative 6, let's plot that. Now what's the distance between the 2 points? Let's see. Well, you know, from here, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I think I actually did that on the automation here. Let's see. Count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can say that there are 12 units between the opposite numbers. We have 6 from 0 to 6. We have 6 units from 0 to negative 6. 6 plus 6 equals our 12 units. $12 units between opposite numbers here. What if I were to give you, let's get another one here. What if I were to give you negative 3 and positive 3? How far apart? How many units apart are those? Well, let's count. 1, oops, hold it up. 1, 2, 3, 4, 5, 6. 6 units apart. 3 units to the right of 0 and 3 units to the left of 0. 3 plus 3 equals 6. So you're noticing a shortcut you could use instead of counting and jumping? So if I said, what is the distance between 7 and its opposite, you would do 7 plus 7 equals 14 units, right? There's a shortcut way to do it. Okay, now you're going to get a chance to try a few of these problems out, and I'll see you back in a moment. Okay, I'm going to bring myself back here. It's time for the homework. Hopefully you did well. I'm sure you did. Okay, we have math book, page 10, guided practice, numbers 1 through 10. And I want you to work in IXL under the category integers, understanding opposite integers. So hopefully that will go well for you, and reach out to me with any questions whatsoever. And I hope you have a great rest of your day. Bye, till next time.